Listen. Any questions from homework stuff? Anybody? I had a few questions earlier. Just to remind you guys, if anybody needs to hear this, if you are doing chapter 2 homework right now, stop. Get into chapter 3, right? Your immediate concern is the more recent homework, because what's happening, of course, on Thursday, I believe that's when I said it was happening, right? Yes. Do you guys remember exactly what's happening on Thursday?
Quiz.
On what?
3, 1, 2, and 3.
Good. 3, 1, 3, 3, 3. Kick-ass. So this Thursday, 3, 1, 3, 2, 3, 3 quiz, which means you want to do the homework so you have questions. So if there's no, let's see, section 2.7. Oh, okay. Was that the one? That was one of the ones I made extra credit, right?
Yes, you made it extra credit till December, I believe. December is
Right.
the day.
So I won't answer questions on it during general class, but you could ask during office hours or something. Is that cool? Or, you know, or is that understood? So somebody was asking me a question from 2.7. That's not really a section that it's an extra credit section. So I'm not going to talk about it right now. Are there any other questions from chapter 3? Okay. All right. I'm an optimistic fool. So I'm going to pretend like that means everything's going fantastic with chapter 3. Let's get back into section 3.3. Let's do some stuff out of the book today. The book doesn't actually get like overly complicated, but I'll show you where the book gets to. It gets to about where we got to yesterday. Let me see, where's a good place to start here? Blah, 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 blah. Where'd that, there it is. Okay, good. Let me start here. Bam. All right, so this little thing in the purple here, this little problem in the purple, how would I solve this problem here? What would I do?
Times.
Yeah.
Times 360.
I love it. And you know you do that because this is division. I want my D by itself. So I'm going to undo what's being done. It's being divided by 360. So I got to multiply by 360. And whatever I do to one side, I have to do to the other side. Right. So I'll show you an example of what goes wrong when you don't. So the 360s go away. So I get D is whatever the hell that is. 0.7 times 180, 1.4 times 90, 14 times 9, 76. No, 14 times 9, Jeff. 126. I don't know what the hell it is. Nobody's going to help me. So you're on your own, Jeff. I think it's 126.
126.
Yay. It took me too long to do. All right. So watch this. I kind of like when they do this earlier, I think, but let me say this right now. We all know that 1 foot equals 12 inches. And we basically used this fact that we just used to solve this equation. We've used it before. So if 1 foot is 12 inches, what's 3 feet? Come on, this is old stuff. How do you know? What did you do? What did you do?
Multiplication.
Good.
Or divided.
Jeez, I'm starting early. Sorry, guys. What did you do? All right. If I multiply both sides by 3, then I get an equation that's still true. That's the whole idea of doing the same thing to both sides. So if I knew that 1 foot equaled 12 inches and I multiply only this side by 10, I get 10 feet equals 12 inches. Holy shit. That's not true. Right? So that's why whatever I do to one side, I must immediately do to the other side also. So it stays true. Okay. So a lot of this is old news for some of you guys, but I really just want that to make sense. Why we do the exact same thing to both sides. It's got to maintain the truth, right? All right. So let me clear all that away. Clear. Oh, shit. I can't move. There you go. Let me see. Blah, 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 blah. All right. And now here's something interesting. Some of you guys might have seen this kind of thing before. Cross multiplication. So let me do this. So this is kind of, all right. I'm just going to show you the general idea of cross multiplication. If I multiply both sides of this equation by 100, what does that do? Why is that kind of a good thing? Because it kills this fraction, right? Do you guys see that? If I multiply by 100, it kills that. So then I get 100d over 360 equals 35. And what's the only fraction left alive? What's the only fraction left alive? What's the only reason there's a fraction still in the equation?
360.
Yeah, the stupid 360. So let me multiply both sides by 360. That'll cancel that out. So I get 100d equals 35 times 360. Is that what I just did earlier? No, this is different. 7 times 180, 1260, is that it? Yeah, okay. All right, let me stop for a minute. That's not the shortcut yet. There is a shortcut. So now what? We're not done with this equation, right? We're not done with this equation, but I want to show you how to get that equation quicker. Do you see how it looks like the 100 just went up there and the 360 just went up there? So that leads to a shortcut. If I take the, I don't know why they have the arrow going that way. If I take the 100 going up and the 360 going up, I cross multiply. 100 times d is 100d, and 360 times 35 is 1260. I get to the same place, don't I?
I think you're missing a 0.
Where am I? Oh, 12,600?
Yes.
Okay. I was off by a factor of 10. Oh, I see what I did. In my head, I made the 7 instead of 70. Is that what I did? Oh, in fact, you guys are like, why did you make it 7? I'm sorry. Because, all right, real quick. Because I said that, let me show you a little side note. How do I do some of this multiplication in my head so quickly? So I got 35 times 360. So if I double this, I can cut this in half. And then I did 7 times 180, but I left that 0 off. Do you see? So that's why I was off by a factor of 10. All right. And do you ever have to do that? No, you never have to do that, but it's kind of neat to see it. Oh, okay. Somebody had to leave. Okay. Anyway, thank you. So I was missing a 0. Thank you. But the important point here is, I'll do another problem down here. Just to finish this problem, if I divide by 100, I get 126. Shaboo! So down here, if I use cross multiplication to solve this, what would the equation become if I cross multiply? What do I get on this side? If I bring the 36 up here, 36 times x, right? So are you guys with me? You guys okay out there? So 36x And then I do the 12 times 15. And I really, really, really want you to understand why this shortcut works. If I wanted to kill the 36, I would multiply both sides by 36. See how it looks like it just went up here? And if I want to kill the 12, I would multiply both sides by 12. See how it looks like it just went up here? I mean, that looks like a horrible football play, I know. And then you take this guy and you take him and you tackle this guy. But that leads to the shortcut. 36 times x, 12 times 15 is 6 times 30 is 180. Use that new trick we just learned. Or not. You can use your calculator. I understand. And then how do I finish that equation off? How do I kill it? How do I solve it? What do I do? At that step where I am, why is the x not by itself?
36.
Stupid 36. So how do I kill it?
Divide.
Divide it because it's multiplying right now. That's how I can kill it. Oh, I like that. Now I'm thinking about, oh, anyway, sorry. I was thinking about The Witcher. How do you kill this beast? You must use division. Anyway, no Witcher fans? Toss a coin to your Witcher. All right, sorry. And then 180 divided by 36.
5.
5. I like it. Kick ass. So let's do some more cross multiplication. I'm gonna let you guys finish copying whatever you're trying to copy from this mess here. And then I'm gonna clear this so I can get some room to do some more cross multiplication. All right, it's gonna go away. It's going, it's gone. Okay. Do they have more cross multiplication? Yes, they do. Try number 2 real quick. Try to use that cross multiplication. So 23. Sounds about right. 22 point something. You're going to need your calculator on this one, guys. So who can tell me what's the step you get to once you do cross multiplication? What's your equation now?
8, 10 equals 35y.
Good. So 81 times 10 is on this side now. 81 goes up there with the 10. And y goes up with the 35 on the other side. And then what do you do to both sides to solve for y? So again, you got this stupid 35. I want to kill it. What operation do I use?
Division.
Division. Die. So what do you guys get there?
23.14 and more.
And more. Okay. All right. I like it. So they should tell you where to round to. Obviously, that's going to drive you a little insane. Or, you know, you could reduce the fraction, but, you know, I'm not going to do that. I don't want to do that. So that's cross multiplication. Now, to point something out, look at number 10 again. Look up here at number 10, just to point out, the only reason we did cross multiplication was because they told us to. What other way could I use to solve this? 12 times what is 36? 3. Are you guys? So what do I multiply by 3 to make 15?
5.
5. So remember the answer was 5? I mean, that's another way, a better way to get that answer very quickly. I can't do that with this problem because the numbers don't really cooperate as easily as these do. I mean, these are nice, 12 and 36. They cooperate nicely. Anyway. So if the problem tells you specifically how to solve it, do it that way. If it doesn't tell you specifically how to solve it, there's a multitude of ways to do it. Okay. I don't like the next point they try to make, so I'm not going to talk about it. Ha, 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 ha.
Yeah,
yes.
even if they
Yeah.
both not denominators or whatever, if they cross multiply and the numbers are nice, you still break it down like you just did, right?
Not sure.
You see how you you had the 12 and the 36 and you went with the 3?
Yeah, if I have a fraction, yeah, if I have a fraction equals a fraction and the numbers work well together, I could just always do what you just did. Yeah, but it's got to be fraction equals fraction. In fact, I really want this understood too. In order to use cross multiplication, you need fraction equals fraction. And then you can cross multiply. See how that's what that shape's in, that's what that's in, that's what that's in.
Right.
If I had an equation that we will have that looks something like this, I can't use cross multiplication because it's not one fraction equals one fraction. It's two shit, I can't cross multiply. Do you guys see that? People try to use cross multiplication in too many places once they learn it. It only works directly in one place. Fraction equals fraction. That's the only time it directly works.
Okay.
So good. I'm glad you said that. Thank you. So let me clear all this away. Boom. All right, let me see. That's too easy. Birth. Let me see. No, that's silly. I don't like that. Here we go. Here comes. Good. All right. So here's a little review from what we did last time. This little dude right there. Can you guys go ahead and solve this number 4 here? Let's see if you guys remember this. That'll be fine. That'll be fine. I'm going to start to catch up to you guys. So hopefully y'all remember. Almost always the first step is distribution, which is what they mean by multiplying out parentheses. They should just say distribution. Most common mistake I see is people distribute this here and then they leave this as 3. That doesn't make any sense. It's going to be 12 now, right? All right. And then what I like to say is there's a bunch of stuff in the wrong place. So what did somebody do next? What's in the wrong place?
X on one side.
Yes. So how do I get the X? What do I do with this X right there to make it disappear? Yeah. Now you could also subtract the 4X instead, but see how that's going to make a negative?
Mm-hmm.
I have the choice. If I don't want negatives to show up, I don't need to make them show up. So I try to keep my variable stuff positive. So now if I do this, I get 3X. The minus 12 is still here. There's the equal sign. And the 10 is still here. And then these X's killed each other. Let me bring my equation up here now. All right, now what's the only thing that's in the wrong place? Are all my X's together? Yes. Are all my numbers together? Dadgummit. So which number is in the wrong place?
The 10.
10's fine. I really want you guys to see why. Which side is the X side? This side is the X side, right? And this side needs to be the number side. So X is on one side and numbers on the other side. So what is in the wrong place?
12.
The 12.
To add 12.
Yes, I love it. You need to add 12. And I really want everybody to see why. I've already picked this side for the X's. These have to go on the other side. So you pick a side for your X's, you pick a side for your numbers, because you want to end up with X equals a number. So then you'll know what X is. And so what's the last step I do here to get X by itself?
Divided by 3.
Yeah, so this is 3 times X. So the only way to kill that is with division. So I get X equals 22 thirds. And you could put that in the old calculator or whatever. You get 7.33333333.
Yes.
But it's just cleaner to put 22 over 3. I don't have to round it or anything. But you could do this and put a little bar on there, right? That means it's 3's forever. It's 3's all the way down. Okay. So one of the most important things you can do for yourself is to be organized with how you set up your equation. So if you do one thing, like you added X to both sides, subtracted X from both sides, everything else stays exactly where it is. There's the minus sign, there's the 12, there's the equals, there's the 10. Don't do stuff on the side and try to throw it back in the equation, because it's going to go in the wrong place. It just will. You want to kind of keep the equation going step by step by step. That's the nicest thing you can do for yourself. Okay. Maybe. So I'm going to clear all that business. It's gone. It's going away. Goodbye. All right. So look down here. This is the great snow cone problem that we can't get enough of. And there is the equation. Is this a different one? I can't remember. There's the equation of this line. Are we cool so far? Right. And there's the actual, right there is the actual x-intercept. That's what you guys had to estimate, I think, somewhere. What does that mean? Can somebody remind me what that point means? Holy crap, that really blew up, didn't it? Jeez. Sorry. I just wanted to increase it a little bit, and it just went insane.
That's where it's now not negative anymore. It's positive.
True. So I'm not losing money.
Mhm.
Break even.
Break even point. And what do I have to do to break even? What's that tell me I have to do to break even?
Yeah, to sell about 300. Yeah, so 389.
If I sell 389 snow cones, I break even. I love it. I love it. So every day I'm like, please go over 389. If I go over 389 several days in a row, I'm starting to build a little bit of profit, right? Then my dream of a snow cone dynasty is closer to being fulfilled. Yes. Okay. So this is the equation. Let me write that equation down on the next page. Oh, shit and a half. 245.63. Okay. Let me see. Get up here. Pew, pew, pew. Dang it. Now I've forgotten it already. What was it again? That's amazing, Jeff. 245. All right, so negative 245 plus 0.63x. Okay. What's the slope of that line?
0.63.
Good. What's it mean?
In this case, every
Yep.
cone that's sold, there's a 63-cent profit.
I like it. So 63 cents more money, increase in profit. And of course, you know, I start negative, so I have to sell some cones. And every time I sell another cone, there's another 63 cents of profit, but I'm starting with negative profit, right? So that's why it takes me a while to 389, and that's where I break even. So that's the slope is kind of rising up until I get to the break even point, and then I start making some actual, you know, positive profit. So everybody with me? So you can definitely have negative profit. Just ask any business, possibly right now. Okay. So how do I find out how much profit for 150 snow cones? What would I do?
Fix the X with 150.
I think I heard somebody say, put that in place of X, because X in this case means number of snow cones. And of course, P means profit. That's crazy. So that's how you do it. You had to do that in previous, if I remember correctly, previous work. So now we just got to figure out what the hell that is. And be careful. I had some interesting talks this morning. Order operations never goes away. You got to multiply before you add this negative 245, right? So you can just put in the calculator exactly like this, and then let me know when you get something.
You want the answer?
Yeah,
It's negative 150.5.
sounds about right. Bucks, right? Dolieros. All right. Not a good profit. So obviously we already knew that 150 was not enough to break even. So we knew ahead of time we were going to get negative profit. Does that make sense? So it's not a bad idea to have a feel for what the answer should be so you can identify a bogus answer. Don't worry about number 2. I don't remember what this shit. Number 3 is a much more interesting question. Try to do number 3. So here's your equation again. Oh yeah, Jeebus. So let me ask you, while you guys are working on this problem, can somebody tell me how many variables are there in this equation?
2,
Good. What are they?
P and X.
P and X, kick ass. So in this problem, 150 snow cones, that related with X. That's why we put it where X was, because X is the number of snow cones I sell. In this case, where am I going to put 50?
At P, because it's your
That's
profit,
crazy.
not how many snow cones you
I love it. Kick ass. So I'm going to put in place of P, I'm going to put 50. And now you realize why the hell we've been doing all this solving equation stuff. Now, this is not pretty numbers, and I don't care, because you're not going to have to, and not until the end of the problem do you have to use your calculator. So let me see. I'm going to give you just a minute to solve this in case you didn't get to this point yet. Go ahead and solve that. Do, 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 do. Why do I have the 18 theme song in my brain? That doesn't make any sense. Ooh, I get something funkadelic. So what's your first step in solving this thing?
Add 245 to the left.
Yeah, so add 245 to both sides. You always do something to both sides because that'll get my term that has X in it by itself. So you find your term that has X in it. There it is. And you say, why is it not by itself? This stupid thing. So let me add it so it cancels. Let me put this up here. So I get 295 on this side, right? 295 equals, this is gone. So I'm just left with 0.63x on that side. All right. How's that? And then what's the last step? Not a pretty step, but too bad. Somebody else tell me.
Divide it by.
Yeah. Yeah. Now see, your brain says, that's gross. I don't want to do that. But you just say, brain, shut up. This is this crap times X, right? Crap times X. I don't want crap. Let me divide crap. Because division is the opposite of the operation. It doesn't matter how pretty or ugly or whatever the number is. It's multiplying right now. So I'm going to divide by it, whatever it is. So let me do the same thing to the other side. And you just throw that in the old calculator. And what do you get?
468.25 and more numbers.
Blah, blah, blah. So I'm going to round it up to 469 because I'm not going to sell like a quarter of a cone, right? Not in my business. Oh, you're a little kid, just want a quarter of a cone. I don't do that here. I sell whole cones. Go away. So round that bad boy up to make a whole number of cones. I like it. I'm so evil to kids. I just am. Snow cones are serious business. All right. I love this question. This is an awesome question. Why is this question in this lesson? That is fantastic. That is a silly question. That's just awesome. Bum, bum. Why is it in this lesson? Because it's exactly what the lesson's about. I have no idea why they put that there. Okay. So that's kind of the level of problem you're going to be working with. So I like to discuss harder problems like we did yesterday, because then when you do the actual homework, it shouldn't be as difficult then, because you've already kind of worked with harder stuff. This is harder because your brain doesn't like these numbers. But you just have to be in control of your freaking brain and say, dude, it doesn't matter that it's 0.63. I just know to divide it. And then we're going to play the old calculator brain. Don't worry. All right, let me clear all this away. Oh, before I forget, cones. You want your units down there for sure. So we have to sell that many cones to have a profit of a whole 50 bucks. All right, I'm going to clear that away. Bam. Oh yeah, we did that number 4. We already did it. To check it, you just plug it back in. I don't care. And then this is, why is number 6 easier than the one we just did? Where would 700 go into the equation? Which variable? P or X? Huh?
P.
So P stands for what?
Profit.
And do you see how I kind of understand why you think that, because you see the word profit, but it says find the profit. If 700 snow cones, so in the equation.
X.
Yeah.
Yeah. I like it. I can't remember now what the hell it was. There it is. So that's got to go in for X. So that's going to be easier than the one we just did, because I'm not going to have to actually do any algebra solving. I just have to throw all that shit in my calculator, right? Because it'll be P equals stuff. So you just throw all this in the old calculator and get your answer. Let's see, what's that going to be, Jeff? 441. Oh shit. So like 196. Is that right? Good old Jeff taking a guess. I'm okay if it's wrong. Nobody's going to help me. All right. 441. Yeah. It's got to be correct. It's correct. I'm going to just call it. Okay, thank you. All right, so I'm going to clear all that. So notice this. Please notice this. When you see a number, don't go start throwing it in the easiest place. You have to say, okay, 700 is snow cones. X is number of snow cones. That's why 700 goes there. If they give you a profit, it has to go here. I don't care that it makes the problem harder. So that's a big problem people have with these kind of problems is they put the number in the wrong place because they don't just stop and say, this means this, that variable means that. It better go in place of that variable. Okay. It's a very simple mistake to make, and it's a very simple mistake to not make. Just take a second. Let me clear all that crap away. Okay. Blah 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 blah. Oh, okay. I love it. Number 9 is neat. You ready? You're not ready. Let's find out if you're ready. I want you to take number 9. They put the equation there again. And what I want you to do is I want you to solve for X. Go. You do all the same steps. That we did before. Let's see if you guys can handle it. You can do it. You can do it. I have faith. Ouch. So the trick is to just realize that the steps don't care. We care that we have 2 variables. The steps don't care. So somebody tell me what's the first step to start solving for X?
Add 245.
Yes, you add 245 because you want to get this piece by itself. Now here's where I get some interesting mistakes. What is P plus 245?
P plus 245.
Yeah, freaking P plus 245. What I often get is somebody will write 245P, but that is 245 times P. That's not what we're doing. We're adding it. So that's all I can write. That's all I can write. I don't know what this shit P plus 245 is. So I write P plus 245. And on this side, what's left? 0.63x. And then I got one step left to do. There we go. That's better. So one step left to get x by itself. I just have to divide by 0.63. And I understand people's brains don't like this. Our brains like it when we're like getting a number. We're not going to get a number because we don't know what the shit P is. So let me collect what we got. We got these cancel. So I got x equals this. P plus 245 over 0.63. So this equation is good if I know the number of snow cones and I want to know what the profit is based off of that. This equation is good if I know what profit I want to make and I want to figure out how many snow cones I have to sell. So remember the earlier problem where it was like, I want to make $50 profit, right? That's the problem we just did a minute ago. So if I use this equation, all I have to do is put a 50 in for P And we will end up with the same answer because we'll get the 295 that we got before divided by 0.63, which is 400 or whatever the hell it was. I can't remember. I really want you guys to get that. So students hate playing around with variables and shoving them around, but we create new equations from old equations. I took this equation and I made a new one. It's better than this equation if I know what I want my profit to be. This equation is great if I know the number of snow cones. Do you guys kind of get that? I mean, I know that some of you guys probably still like, we're just shoving shit around, whatever, man. But we're creating new equations from old ones. That's what makes the world go round. So there will be some problems in the homework where they will not tell you what the variables are. They'll ask you to solve, just like we did on this problem. You're going to have to work with other letters. So what do you do? It's actually better. You don't have to actually do shit. I don't have to add that. I don't have to divide that because I can't. I don't know what that is. Student pointed that out a long time ago. I'm like, yeah, exactly. It's actually easier in a way. I don't have to do it. I just have to write the shit out. Okay, maybe. Let me clear all this away. Go away. All right, I don't care about when they do this Excel shit. Let me see. There's the Fahrenheit and Celsius stuff. I don't care. Oh, here we go. All right. Here's a really great example. Here's one that has 0 numbers in it. So try to do this problem. This is the time to make mistakes right now because it's not going to cost you any points. Try to solve this equation for t. Get t equals something. Try to get t by itself. Ooh, watch. So if you're having any trouble with this, I like to do this kind of thing. Sure. Can you guys see how that's the same equation? So I just made A20, I made P10, and I made R1. Same equation. How would you solve for t over here? You would subtract 10, right? Yeah, there's stupid little line. So you get 10 equals 10t. So over here, what are you going to do? You're going to subtract p to get this by itself. And what's a minus p? It's a minus p. Those cancel. And your last step over here would be divide by the stuff in front of t. So the last step here is to divide by the stuff in front of t. And again, I can just sense some of you guys like we're just shoving letters around. But what we have done is we have created a new equation out of an old one. That is better if I want to solve for time and I know this other shit. Does anybody remember what does that formula relate to? Do you guys remember? P and R and A and all that stuff. Do you remember what that is? That's the principal and the rate and the time and the amount and the account. Remember that? No? You're like, nah, dude. I immediately forget that shit. All right. Yes, it's the interest formula. Exactly. It's the amount that's in an account that earns so much interest. I love it. Simple interest. All right. I'm going to clear this away. So before I clear it away, if you know how to solve this equation, you must know how to solve this equation because the steps are exactly the same. I know that one of these has no numbers in it, which is even better. I don't have to do a minus p because I can't do a minus p. That's kind of nice. I just can write it. And then when I divide by PR, I just write the over PR. I don't have to do it. I can't. Maybe. And you guys are all still like, no, just give me numbers, man. All right.
So I'm sorry, you divided by, oh, right when you cleared it. Sorry about that.
Sure.
So when you divide it by P and R, so it's only when there's two variables being multiplied, can you divide by both of them at the same time?
Yeah, if I divide by PR, doesn't that kill P and R?
Yeah, I get, okay, that makes sense.
I like it. So that's a good point. Whatever's in front of the variable that I want, if it's multiplying, I divide by it. So here there were two variables. So yeah, I could have a situation where I have several variables. I want to solve for X. I'm going to divide by ABC because it would kill the A, kill the B, kill the C, and then my X would be by itself. So it's a good point. I like that. Okay. Let me see. I'm going to clear that. Bam. I like it. Look at all the space here. I need some more of this. Awesome amounts of space. Look at this. A whole page of space. It must be coming up to the homework. Yeah. All right. All right. So homework. I already got some questions earlier from the homework, so I'll let you guys get in there. I think I changed the due dates for the homework. I can't remember now. I can't remember if I had to change those. I want to look ahead to the next section. Let's see. Here we go. Let's do some of this. So next section is going to involve some inequalities, apparently. I'm going to let you do these. We've talked about inequalities before. So what's going to be interesting is how does solving an inequality, how is it different than solving an equation? So, for example, if I had the equation x equals 3, this is kind of a silly question, but how many things make that equation true? This is kind of silly. That might even be too silly to even understand what I mean by that. Only one thing makes it true if x is 3, right? But if I have the inequality x greater than 3, somebody give me a number that makes that true. What can I put in place of x to make it true?
4.
Crazy. What else?
Anything above 4. Or
anything above 3, yeah. 3.000001 works, right? That's greater than 3. So anything from 3, a little bit above 3 and up. So 99 works. What about the square root of 75? Why did you do that, Jeff? I don't know, just because, to make it freaky. Anything bigger than 3 makes it work. Obviously, of course, what makes it false? Give me a number that makes it false. It's never false, Jeff. All right, there we go. I got somebody motioning to me. 2 makes it false. 1 makes it false. Negative 15 billion makes it false, right? Because they are not bigger than 3. Okay, that's simple. That's not that big of a deal. But I want you to realize, what does this mean? When I solve an inequality, I could very well get an infinite number of answers. That's what that means, right? With an equation, I normally get one answer. In inequality, I automatically get, well, most of the time, an infinite number of answers. Okay, I like it. Which is why we're going to want to create a way to give the answer without listing them all, because that would take the rest of my life and the rest of my kids' lives and the rest of their kids' lives. All right, let me see where they're going to go. Oh, I see where they're going with this. Okay, I like this. Shit, I hate, sorry, I don't want to skip something here. All right, this is crazy. Let's see. Here they're just trying to show you. Okay, let me jump to the chase. So when I go to solve this, one of the simplest ways to give the answer is visually on a number line. So the nifty thing is there's only one difference between solving an inequality and an equation, and we're not there yet. So what would your gut say to solve this? How would I solve this inequality here?
Add 5.
Add 5. I love it. So x is greater than 14. Be really careful. You got to keep that inequality symbol coming down, right? Don't just suddenly make it an equal sign. That doesn't make any sense. So if I were to graph that on a number line, and now I'm not sure, shit. I want to use the same symbols they use in the book here, because it depends. What page is this? 330. Okay. All right, so they use the circles. So let me ask you this. And I should have made this point earlier. Obviously 15 works here and 16 works here, right? Obviously. Does 14 work here? Is 14 bigger than 14? No. So the basic idea is I'm going to shade where all the answers are. So 15, 16, so I'm going to shade up. And then I'm going to put a circle on 14. Do I shade that circle or not? Well, if I'm shading where all the answers are, is 14 an answer?
No.
No. So I'm not going to shade it. I'm going to leave it what we call an open circle, not a closed circle. So that means that 14 doesn't work, but everything above 14 works. And what's really, really nice is, oh, go ahead. Sorry.
I vaguely remember like using like a parentheses or
yes, that's what I was checking. I didn't know if they, so sometimes you'll see parentheses instead of open circles and brackets instead of closed circles. Yes. And that's when we're going to interval notation, right? So I just want to use the same symbols the book used, and the book uses the circles instead of the parentheses and brackets. You guys with me? I'll take that as a yes. What was I just saying though? Shoot. Oh. Notice, look at the symbol. Doesn't it look like an arrow? Oh, somebody's got a chat for me. Oh, okay, understood. Doesn't that look like an arrow pointing this way, right? So I shade that way because that's the arrow says to go that way. So that's another quick way to shade in the correct direction. So you guys do this one. Go ahead and solve that and graph it. I'll sit here and do nothing. Good job, Jeff. All right, so the actual solving shouldn't be that big of a deal. What do I do to both sides? What do I do to get t by itself?
Subtract the.
Oh shit, come on. There we go, sorry. Yeah, subtract 11. So that'll go away. So I have t less than or equal to, what's that? What's 5 minus 11?
-6.
-6. All right. Notice how I really don't give a shit about all this other I don't care. It doesn't matter. So -6 is the most important thing. There it is. Which way am I going to shade?
To the left.
to the left. I like it because it's less than, and it points that way. So I'm going to shade this way. And what about the circle on 6? Am I going to shade it too?
Yes.
Yes, because it's allowed to equal -6. Now, I like what Vu said earlier. What kind of sucks. So the other way to do this is to put a bracket on here, and I kind of like to teach that because then I can talk about Dragon Ball and how it looks like the hands and the Kamehameha. Oh, Kamehameha. Anyway, if you don't know Dragon Ball, you're not missing out on anything. But here we're using these circles. That's fine. No Kamehameha.
Dragon Ball is awesome.
I agree. I agree.
I think they're on GT now, I think.
Oh yeah. If you like Dragon Ball, look up Team 4-Star. Dragon Ball Abridged. It's kind of like a. Anyway, that's enough of that. Sorry. Some of you guys are like, I don't give a shit about Dragon Ball. Understood. Let me clear that. And this check is kind of dumb, to be honest. If I pick a number that's over here, is 20 bigger than 14? Check. And in here, if I pick a number back here, like -8, is -8 plus 11. I'm going to put a -8 in place of t, right? Is -8 plus 11 less than or equal to 5? Is 3 less than or equal to 5? Check. Right, so you check it really the same way. You put an answer into the inequality. I should have put it here, but too bad. And then you make sure that it works. Make sure that it makes it true. So when you shade, that means that everything here makes this true. That's what that means. And so this side, so this is like Giants fans and Jets fans. So this side does not make it work. Okay. Let me clear that. You guys are like, let's see, Dragon Ball, football. This is fantastic. All the shit I don't care about. I'm sorry. So let me clear all that away. Go away. What time we got? What time we got? Okay, not too bad. Blah, 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 blah. Oh, this is interesting. So write a verbal description of what the solution says to the two inequalities in color box. What are we talking about? What colored box? What are you talking about? Let's skip that. That's weird. So here, I think you guys pretty much get it. I want to focus on what the. Here we go. Let me do something better than what they got down there. All right. Here's the one difference. The one difference in solving inequalities, and for some reason it has to do with what I'm about to do. Which one of these is bigger? -2 or 1? One's bigger. So I would do it like this, right?
Yes.
So -2 is less than 1. That's groundbreaking. I know. Earth-shattering. I'll give you guys a moment to collect yourselves. Now, if I divide both sides by -1, what does this become? What's
Positive.
-2 divided by -1? +2. What's 1 divided by -1?
-1.
Which one's bigger now?
2.
What did the sign do?
Yeah, it flipped.
Flipped. There you go. It flipped. So if I'm solving an inequality, so if I had this little tiny inequality, for example, what would you do to both sides to get x by itself? What's understood to be here?
You have to divide the negative.
Yeah, divide by -1. And what did we just figure out here? Anytime you divide or multiply both sides of an inequality by -1, what does the inequality symbol have to do? It has to switch. And I really want that to make sense. So here I have -2 and 1. And when I multiplied by -1, that became +2 and 1 became -1. So when I multiply or divide by a negative, I switch what side of the inequality they're on. So the one that used to be less is now greater. Anytime you multiply or divide by a negative number in an inequality, this sign has to flip. It has to, because I've changed the side of the number line that they're on. Does that make any sense at all? No, Jeff, you never make sense. All right, let me do one more thing here. I'm going to do this problem in a different way. I'm going to do this problem in a really weird way. So I'm going to add x to both sides. That is weird. What's negative x plus x? That's right, kids, 0. And then I'm going to subtract 3. Can somebody read what this says for me?
-3 is greater than x.
Good. Now read it backwards. X is
Less than -3.
yes, which is exactly what this says right there, right?
Yeah.
Okay, so that's another reason why the inequality symbol has to flip, because if I made the variable positive on the other side, it's on the other side of the symbol. I don't know if that. So if I don't do that, if I take a shortcut and just divide the negative away, that's gotta flip. So there's 2 ways to see why that inequality symbol has to flip when you multiply or divide by a negative. So look at this part B down here. This could be a trick question. What would you do to solve this?
Subtract 6.
Subtract 6. Do I flip the symbol?
No.
No, good. So some people take what I said up here and they say, okay, anytime I see a negative, I flip. No, that's not what I said. If you multiply or divide by a negative, the symbol flips. Did I multiply or divide by a negative? No, I subtracted 6. So of course the symbol's not going to flip, right? Maybe. Maybe. So 8 is bigger than 4. Is that true? Okay. If I subtract 6 from both sides, I'll get 2 and -2, and it's 2 is still bigger than, see, the sign didn't flip. Why would it flip? This is bigger than that, and then I subtract something. It preserves the order. It preserves who's bigger. Dividing or multiply by a negative doesn't preserve who's bigger. It flips that situation. I don't know if that's too much, Jeff. I'll stop talking about that. Okay.
Followed.
Say again, sorry.
I followed that.
Okay, thank you, thank you. Let me clear all this away. That's the one thing you have to watch out for. Otherwise, it's the same exact thing as solving equations. But this is the one difference, the one thing to look out for. All right. Let's see. So go ahead and do this problem over here, and then we'll call it a day. Do the 3Z one over. Let me really make sure with this problem. Do this problem. Oh, yeah. Oh, man. I'll be real careful that the old mistake of like adding 3 sometimes creeps in here. We know that's not what we're supposed to do. So what do you do to both sides here?
Divide -3.
Yes. Divide by -3. So those cancel. So I get z. 12 divided by -3 is -4. And what do you put in the middle?
The less than or equal to. Flip the
Yes.
symbol.
Kick ass. So then you put your -4. You're going to shade that way because that's the way the arrow is pointing. So I'm going to shade to the left, to the left. And then what am I going to put? Am I going to fill in that circle there?
Yes.
Yes, because it's allowed to equal -4. Kabam.
Confused on when you're supposed to divide or subtract or add
I'm
3.
sorry.
Because I would have added 3 to both sides. Like, why would I divide? Like, how would I know if I divide?
If you add 3, can you combine these? Are these like terms?
No.
No. So I want you to, and this is what I was saying, that old mistake that I talked about before. What is the operation here?
To get z by itself.
What's the operation though in this expression right there? What's the operation? What are they doing to each other?
Multiply.
-3. Yeah, multiplication. So the only way to undo multiplication is to divide. You have to divide. Yeah. But I understand that's the easiest place to make that mistake because our brain says, oh, that's freaking -3. So I'm just going to add 3. But we have to say, no, brain, the operation is what I kill, not the number. I don't kill the number. I kill the operation. So it's multiplication. I must use division to kill it. So I'm not coming down on you for sure, because that's the most common mistake. And it's understandable. Our brain sees negative, so it thinks positive. But you have to think about what the operation is and attack it. I like it. Okay.
Well, I also want to say that I think people are getting that confused because if you have z on the other side as well, you have to add like terms, and people I think maybe confuse the two.
I see.
Does
So
that-
it's
yeah.
Yeah, I got you. So if I had a problem like this, 4z plus 2 equals -3z minus 5, right?
Right. Yeah. Then you have to add the like terms, and then it would become z equals whatever, and then you divide or times. I think that's what people are doing and why they're doing it.
All right. You might be right. I think so. But the operation that is making this be here is not multiplication. It's actually addition, subtraction kind of stuff going on, right? And that's why I have to add 3z. That's the operation that will make this piece die. And again, I got like that. I made an underline there. Let me get rid of that so it doesn't look like division. So it's always, whenever I do something, I have to make sure that what I just did actually makes the thing cancel. -3z plus 3z cancels. So then I get 7z over there. And then I can subtract 2. Now is where I say, how do I kill the 7? And that's connected by multiplication. But that's a good point. I like that. Thank you. That's one other thing that could be in people's heads that makes that mistake easy to do. Okay. I think that is enough for today. So I'm going to call class. It's over. Let me know if you need to wait afterwards. Let me know if you have any questions. Otherwise, you are free to go.
Bye.
See you. All right. I'm going to head out. I don't see any questions. I'll see you guys. Take it easy.